Hi, this is the replacement lecture for September 25th. Unfortunately, I missed the lecture. The aim of this lecture is to introduce to structures and pointers. I understand that Chris has already covered pointers, but several students came to me and told that they have difficulties. So I thought we can again review pointers and then I'll go to structures. Now, this picture of the RAM is familiar to us that every location of the RAM, we are not talking about pages, but individual locations of the RAM, there is an address associated with it. And when we declare something like int I am basically allocating a storage for the variable I. The confusion about pointers come from the fact that as we can store a variable, we can also store the address of a variable. So for example, I can write int star I. This is an additional syntax in the C language that indicates to the compiler that I am allocating storage for the address of a variable. The variable is called I. So the picture in the RAM will be that whatever is stored here will be interpreted as the address, and if we go to that address, we'll find the variable I. After this declaration, the variable I doesn't exist yet. That we have to see soon in code examples how we can do that. Now we can extend this idea to any level we like. For example, I can write int star star I. That means I am allocating a storage for a location where an address will be stored. And what is that address? That is the address of a variable called I. And if I follow from there, I find the variable I. So this is why you can see that they look like pointers. So that is why it is called pointer in C. So we have to remember this image as we progress through this lecture. So here is a very simple code segment with the usual include files at the top. And I have declared two variables. One is I and one is not a variable but a pointer to an integer variable. So I can directly assign a value to I. For example, I have assigned I equals 10. However, I cannot assign a value to j because j is not yet a variable. J is simply an address of the variable. So to store something in the location for j, we have to first allocate space for that location. And that is done, you are familiar with malloc, that is done by allocating space for an integer. And we have to do the usual typecasting in C to cast that reference of that storage location to an integer pointer by this int star. Now J really stores the address of a location that exists in the memory after this memory allocation. And now I can use this syntax to store a value 15 in J star J, because remember J is an address. So that is why we need this new syntax to indicate that whatever this is called the content of J. So J is an address and content of J I am assigning the value 15. I can now print out the two values I as usual, but for printing out the value of J I have to again use the syntax star J. So that is the new syntax we have encountered, that whenever we have a pointer to an integer or pointer to anything for that matter, to get the value of that variable, we have to use the syntax star in front of it, or to assign a value to that variable. So let us look at another problem where I have used a double pointer. So in this case, I have declared a variable called a, assigned a value of 100. Now, this is another syntax that you have to get familiar with. We have 4 things to remember. We have seen the star syntax already. And here, what I am doing is I am extracting this ampersand a, means I am extracting the address of a into a variable which is a pointer to an integer. So it is the picture that I have shown you in the first slide where I use double star. So in this case, I can declare an int star star dptr double pointer and store the pointer, this value, the address of this pointer there. So now dptr has become a double pointer. That means once I follow it, I go to ptr. Second time I follow it, I go to the actual variable a. So I can do all this now, print out a, and many different ways. Directly I can print out a. I can print out a by using the pointer to a, and I can print out a by using the double pointer to a. So basically they all point to actual location of a. Now here is some very important points regarding allocating storage. Most of the time the problem comes because novice programmers or beginning programmers, what they do is they declare a pointer to some variable but forget to allocate space for that variable. So to illustrate that, I am here doing a bit complicated thing. Actually, what I am doing is I am doing allocating space for a 2-dimensional array. Now it is a small array. There are 2 by 2 array. That means a 2-dimensional array is nothing but a matrix, if you are familiar with that. So first I am allocating an array of pointers. There are 2 entries in that array, and each of those pointers will point to an array of integers. So that is the idea. Now I am declaring a star star my pointer, just like in the previous slide where it is a double pointer, and I am allocating size, how much, to my int is 2, so 2 times the size of an integer pointer. So you can see the result of this is, after this is executed, this my pointer is becoming an array with 2 entries. Each entry is a pointer to an integer. So I can treat my pointer as an array. And how do we use an array? By indicating the index of the array. So I can say my pointer 0, which is right now a pointer to an integer, but the actual integer that it is pointing to, I have to allocate space for that. Exactly, that is what I am doing here. I am allocating space for an integer. Similarly, my pointer 1, I am allocating space for an integer. Now what I can do is I can use the same notation, the star notation, to store a value star my pointer 0 is 20, star my pointer 1 is 30. So I can store these 2 values and I can also print them out. I have done a kind of dirty pointer arithmetic here. You are familiar with this. Basically, the name of an array is the starting address of the array, and I can add 1, 2, 3 to go to the subsequent locations of the array. So this is not something which you don't need to do really. You can always in your program, I would highly recommend that you stick to only one pointer. Double pointer is not necessary, but I just wanted to show you. Now we come to structure. Now, one of the problems with single arrays is that you can only store a single value in the array. But many times we want to store multiple uh, pieces of information inside an array. For example, if I am storing the student record, I want to store the name of the student, I want to store the number of the student. How do I do it? Of course, it is possible to do it by declaring two different arrays. One will store the name, another will store the number. But the problem there is if you do strange things to the arrays individually, then everything will get mixed up. But here, by declaring a structure, I keep them together. So that is the idea. So it is declared like this: struct student. I have given the name student, where there are two, we call these fields. One is a character array of length 10 to store the name, and another is an integer to store the student number. And now I declare two variables called stu1 and stu2 to create two instances of the structure. So this is the complete declaration. I am declaring a structure as well as creating two instances of the structure. Now, this is very important to note here that stu1 and stu2 already have locations in the memory. May not be a single memory location, but of course multiple memory locations, where part of the memory locations is name and another part or one memory location for number. Similarly, stu2 also has been allocated memory after this declaration. So here we don't have any problem with memory allocation because we are directly allocating memory. What I can do now is in stu1, I can copy the name Amy in the name field and assign the number 10 in the number field and print them out in the usual way. One important thing to note here, that when you are like this, when you are directly allocating memory to access a field of a structure, we use the dot operator. There is a dot between stu1 dot name, stu1 dot number. So this is the way to access a field of a structure from the name of the structure using the dot operator. Now, there is one last thing that we have to understand, and that thing is how can we use a structure name as a new type in our program. When we declare, we are used to all the data types like integer, float, character, double, etc. Now, by creating the structure, we have created our own data type called student, and we can use this as a new data type. We can declare pointers to this data type and all sorts of things. So here I have shown you in this simple code how to declare pointers to this structure. So this part is same, struct student, which has two fields, name and number. And now I can declare pointers to them. So I write struct student star stu1 star stu2. That means these two are pointers. As compared to the previous slide, we haven't yet actually allocated space for stu1. We have only created a pointer. So in all situations like this is the single most important mistake that beginning programmers make. That once you write this line, your stu1 and stu2 don't really exist yet. So what I have to do now is I have to allocate space for this. This is a pointer, allocate space for this record, the structure, and connect the two. So the allocating space is again same, almost similar to what we have seen. We use malloc and we tell size of struct student. So struct student is our data type. Instead of integer, for example, in the previous slide, we write struct student and size of that. If you recall why we do, instead of writing a number here, you do this to make your code portable. That means no matter where your code is executed on a 32-bit machine or 64-bit machine, depending on the size of the basic data types on that machine, your integer and character will be allocated the correct space. So we write that malloc, and what we get out of malloc is actually void pointer. C has this notion of void pointer. That means C is a strongly typed language. Whenever we write a statement, the right hand side of the statement and the left hand side of the statement, their types must match. So that is why we do this type casting. We are casting these void pointers to the address of a student data type, struct student data type, and storing at stu1. And everything is fine now because stu1 is a pointer to the same structure, and the right hand side after evaluation is returning a pointer to the same structure. Now what we can do is, and this is the last bit of notation we have to learn. Now stu1 is actually the pointer to a structure. When we use a pointer to access the field of a structure, we have to use the arrow notation. So this is a minus sign and a greater than sign. So we write, when I am copying again the name Amy into the name field, I write stu1 arrow name comma Amy. And similarly, when I am assigning 10, I write stu1 arrow number. And now I can print them out in the usual way, again using the arrow notation. So these are the two things we learned. We learned how to write a structure, declare a structure, how to declare pointers to a structure, and whenever we declare a pointer, we have to be mindful that we allocate space for the associated data type. Here we have created a new data type. Earlier slides we had int data type. So we have to create space for that or allocate space for that. And you know by now this space is allocated in the heap. So let us extend this code a little bit more. So here, this part is same, struct student, which has two fields as before. Now, I don't want to write every time struct student, this pointer, struct student, that pointer. Instead of that, I am saying the compiler that from now on, I am declaring a new data type called uppercase S. This is called student, which is of type struct student. So type def struct student student. Now student has become a data type exactly like your int, float, char, double, etc. I can use this name student *stu1 *stu2 like as before. So the only difference is this type def. That is why we call this as a user defined data type. The rest of it is the same as in the last slide. We allocate space and we copy the name Amy and copy the number into the number field. Note here that I haven't allocated space for STU2. So if I have to store the details of another student called, let's say, John, then I have to allocate just as I have written STU1 equals all these. I have to write STU2 equals all these, and then I can use that. So the space allocation is most important. Now here I have I have used the same two ideas that we have learned, that either we can directly declare structure or we can declare pointers to a structure and allocate space ourselves. So here another way, I have directly allocated an array of structures. There are only two elements in this array, two entries of type student, our user defined data type. And now I can, since I have directly allocated, there is no pointer here, then I can use the dot notation. So stu0 dot name, I can copy Amy, and number I can assign 10, and I can print them out using the dot notation. And here I have done the pointers. So again, everything is same here, and you can see that type def struct student, the user defined data type. But now I am declaring uh, a pointer or an array of pointers to this data type. Now, whenever I declare an array of pointers, I don't have really the space for those structures yet. And so I have to allocate space. So here I am allocating space in a for loop. So you can see that this is the index of the for loop, and there are only two entries in this array, and STUI is the index. I simply write the same thing, student star malloc size of student. So since this has become our user defined data type, I don't have to write any more struct student like here. I can use the name of the user defined data type. And since now this is an array of pointers, I can use the arrow notation to 0 and arrow notation name. I can copy the name Amy, and also I can assign the number 10, and we can print those out using the arrow notation. So I'll stop here, but I will again appeal to this picture and would um, would request you to basically understand this picture well. When we are declaring a variable, we are directly allocating space. When we are declaring a pointer, we have only the space for that pointer. We don't have space for the variable yet. So once we allocate that space, as we have seen using malloc, we have space for that variable, and now this address will point to that variable. And similarly, we can have, this is simply called two levels of indirection, pointer to a pointer. You can do int, you can write 7 pointers I, but of course that will be very confusing. So at the most 2 pointers, but most of the time we can use 1 pointer. And here basically this stores an address of an address, and that points to an address, and that points to the actual variable. So I hope you can go through these and think on your own, and in the tutorial we'll discuss these as well as the second project, which will require some ideas from here.